This is the third video for the 7.1b lesson. Now we're going to start to we've been doing a lot of explanation in understanding what a function is, and now we're going to get into doing some number crunching and using the notation. It says, given the function, so it's going to start to give us a function. So this one's giving us f of x equals 2 minus 3x. So first of all, I can tell that this is a line because that is essentially slope-intercept form, although maybe it's out of order a bit. We're going to evaluate the function for a value of x. And this is the way that we now write this. It's shorthand. It's read f of negative 2, which means what is the f of x value or the y value when x is negative 2? These are the same as these ones, but I'm just going to do them over here so you can I can more easily see the instructions when I do this. So this is my x value. I have to now start to know that. This does not mean multiply by negative 2. It just means we're going to plug it in for wherever x is. And this is our x value. So it's going to be 2 minus 3 times negative 2. So we're going to input negative 2 in for x. Just a fancy way of doing something that we did since module 1. And this is 2, negative 3 times negative 2 is 6. 2 plus 6 is 8. So our answer is 8. That's it. So we could say f of negative 2 equals 8. We don't need to do that. We also know that this is the ordered pair negative 2, 8, because x is negative 2 and y, or f of x, is 8. But for the purpose of the Desmo slide, we can just type in 8. Let's try another one. This time we're going to plug in negative 2/3 for x into this function rule. 2 minus 3 times negative 2/3 is 2, cancel these, plus 2, which is 4. All right. Then on a slide, I'm going to leave one of these for you to try, and I'll also toggle over to the Desmo slides now. We're going to state the domain and range for these. So the domain for these have been, we've had negative 2, we had negative 2/3, and we're trying to do these in order. And then I'm going to leave a spot for the last one, which actually I think goes here. And then the range was, we had 8 and 4 currently. And then there's one other range value, and you need to figure out where it goes in that list. So domain and range is x's and y's, and listing them out in that set notation. So let's go in here and enter these in. So we figured out that this was 8, or if you'd rather write f of negative 2 equals that. Either way it works. All right, next one, we did negative 2/3, which was 4. And you can share that. And you're going to try this one. And then you're going to list out your domain and your range. So we just did that. You're just doing this deal, which was negative 2, negative 2/3, and 1/6, right? Spoiler alert, they already gave us the other part of the domain because they gave us the 3 x values. And then you can fill in the range there as well. And then there's this question, which also sort of really tests our understanding of this notation. It says, given the function f of x equals 2 minus 3x, same one, what values of x makes f of x equal 0? Or when is y equal to 0? So we're just going to essentially do that. We're going to set f of x equal to 0. So our function rule for this one was this. And so we will set y, or f of x, equal to 0. And you might ask yourself, what are we solving for here? This thing has a name. It goes back to, maybe it was module 3. And it's 2/3. And so we found that when x is 2/3, y is 0. What's this thing called? Oh yeah, the x-intercept. We just found the x-intercept, right? This was just a fancy way of saying x intercept. And so we'll enter that in. So x is 2/3.